Hello everyone and welcome to the lecture Internet of Things. I'm Neda and today I'm going to talk about messaging protocols and data formats. First of all, we will have an introduction to MQTT and MQTT basic concepts and how to set up an MQTT broker and what are the data serialization formats, and also we will see the first part of our assignment today. So MQTT stands for Message Queuing Telemetry Transport and is a simple messaging protocol that is designed for constrained devices with low bandwidth. So it's a perfect solution to exchange data between multiple IoT devices and connect these devices and sensors to the cloud. MQTT works based on the publish-subscribe model, which means that devices publish messages on a specific topic, and all devices that are subscribed to that topic receives the message. In MQTT, all IoT devices at the same time are client and server, which means that a device can publish a message on a topic, or it can be subscribed to a particular topic to receive messages. The main applications of MQTT include sending messages to control outputs, reading and publishing data from sensor nodes, and much more. In MQTT, there are a few basic concepts that we need to understand. There are a publish subscribe, or we call it PubSub, and messages, quality of service, or in abbreviation QoS, topics, broker, and client. You can also go and see this link that is all materials about MQTT, mqtt.org. So let's see first a concept that is MQTT publish subscribe. In a publish subscribe system, a device can publish a message on a topic, or it can be subscribed to a particular topic to receive messages. So as you can see in this picture, device 1 publishes on a topic, and device 2 is subscribed to the same topic that device 1 is publishing. And then device 2 will receive the message. Is exactly like this, so simple. So device 1 publish and device 2 subscribe and get that message. MQTT messages. We said that MQTT uses a publish-subscribe messaging model, where messages are sent from a publisher to a broker, which then forwards the messages to one or more subscribers who have expressed interest in receiving messages on a particular topic. But what is an MQTT message? An MQTT message is a packet of data that is sent from one device to another over the MQTT network. The message contains a payload, which is the actual data being sent, as well as metadata such as the topic the message is being sent to and any QoS settings. A few examples of how MQTT messages can be used is like a weather station publishes temperature and humidity data to an MQTT broker on a specific topic, which is then subscribed to by an IoT device that controls the greenhouse temperature and humidity levels. The IoT device receives the data and uses it to make decisions about when to turn on or off the greenhouse heating and cooling systems. A smart home hub, for example, publishes commands to turn off the lights in the living room to an MQTT broker on a specific topic, which is then subscribed to by a smart light bulb. The light bulb receives the command and turn off the lights in response. Quality of service. MQTT defines 3 levels of quality. 0 is it means that the broker or client will deliver the message once with no confirmation. And number 1 means that the broker will deliver the message at least once with the confirmation request. It means that it want to be assured that it gets the message. And number 2 means that the broker will deliver the message exactly once by using a 4-step handshake. So as you can see, higher levels of QoS are more reliable, but involve higher latency and higher bandwidth requirements. Let's see one example of what an MQTT message might look like. MQTT message has one header and one payload. In the header, we have topic that, like, for example, let's say it's home automation, and this is home. In the living room, lights. The lights in the living room in a home. This is the topic. And QoS is one that means that delivery is guaranteed, delivery of the message. And the message ID is 1, 2, 3, 4. And the payload is on. For example, we want to make the lights on. This is how the MQTT message looks like. But we have also in binary. Actually, the MQTT messages are usually sent in a binary format to minimize network overhead. So this example would be represented in binary format rather than plain text. Note that the header is represented as a series of bits with the first byte 0011 and 1000, indicating that this is a published message with a QoS level of 1. The remaining length fields indicates the length of the variable header and payload combined. In this case, 2 bytes for the variable header and 3 bytes for the payload. And the variable header contains the topic, which is represented as a series of bytes in UTF-8 encoding, and the message ID is also included in the variable header. The payload contains the string on, which is also represented in UTF-8 encoding. And overall, while the binary format of an MQTT message may look complex at first glance, it's designed to be a lightweight and efficient way to send data between devices in the Internet of Things and other connected systems. So, what are the examples of this message, how we use it? A weather station that publishes temperature and humidity data to an MQTT broker on a specific topic. And this data is subscribed to by an IoT device that controls a greenhouse temperature and humidity levels. And the IoT device receives the data and uses it to make decisions about when to turn on or off the greenhouse heating and cooling system. Another example is that a smart home hub publishes commands to turn off the lights in the living room to an MQTT broker on a specific topic. And this command is then subscribed to by a smart light bulb. And the light bulb receives the command and turn off the lights in response. Another example, maybe it can be a security camera that publishes video footage to an MQTT broker on a specific topic, which is then subscribed to by a, let's say, cloud-based storage service. And the service receives the footage and stores it in the cloud, where it can be accessed by the camera owner from anywhere in the world. The next concept is MQTT Topics. Topics are the way you register interest in incoming messages or how you specify where you want to publish the message. Topics are represented with a string separated by a forward slash, as you can see here. And each forward slash indicates a topic level. This is 1, 2, 3 levels of a topic, and this is a level separator. And topics are case sensitive. As you can see here, home office lamp is not equal to home office with LA cap lamp. So there are two different topics. An example of how you would create a topic for a lamp in your home office, this is how the topic will look like. So MQTT topics are used to route messages between publishers and subscribers. Another important concept is MQTT Broker. The broker is primarily responsible for receiving all messages, filtering the messages, deciding who is interested in that messages, and publishing those messages to all subscribed clients. Think of a broker as a post office where multiple clients or devices are sending the message. In the example of the post office, we can say messages are like the letters. And the broker, as a post office, sends these letters or messages to designated clients. You can see in this photo that all devices are publishing on this topic. For example, this topic is house office lamp, house kitchen door, and house room window, and or the other devices that they are subscribing to. For example, this device is subscribing to this topic, and this device that is in purple is subscribing to this topic, and this device is subscribing to this topic. So MQTT Broker is responsible for getting the messages and sending them to the right subscribers. But what is a broker? Broker is a software that is running on a computer or on premises or in cloud. MQTT does not use the address of the intended recipients, but uses the subject called topic, and anyone who wants a copy of that message will subscribe to that topic. Multiple clients can receive subscribe messages from a single broker, that is one-to-many relation, one broker and multiple clients. And it can be the opposite. It can be the opposite, and it means that multiple publishers can publish topics to a single broker. So we will have many-to-many clients relations that both publish on and subscribe to topics. Also, MQTT uses encryption both for data in rest, the feeds and topics, the data that is exist, we call it data in rest, is stored somewhere, and the data in flow, that the data will go in the communication, we call it data in flow, and it means we need some connectivity credential when we are working with the broker. Also, in MQTT protocol, a written message is a message. We know that broker can store the data in the form of written message, and the written message is a message that the broker saves after it has been published with the written flag instead. This means that the message will be stored by the broker and made available to new subscribers who connect to the topic to which the message was published. By using written messages, a subscriber can receive the most recent data published to a topic, even if the publisher is currently offline. This can be useful for applications where it is important to always have access to the latest data, such as real-time monitoring applications. And the broker keeps track of the all sessions. Broker also keeps track of all the sessions as the devices goes on and off, and it is known as participant session. We have several brokers that we can use, such as Adafruit.io, Node-RED, Hive MQ, Mosquito and RabbitAQ. Many other difference. In this lecture, we will learn how to work with Adafruit IO MQTT Broker, and we will see how to create a MQTT Broker and how we connect, how we test it and debug it if it works finally or no. But I kindly recommend that look at the other options and see how are working if you like. Otherwise, we will go through Adafruit IO. Adafruit IO is an MQTT broker designed specifically for IoT applications, and it offers a user-friendly interface for creating and managing MQTT feeds, as well as tools for visualizing data and triggering actions based on incoming messages. And Node-RED is an open source tool for building IoT applications that can also function as a MQTT broker. It provides a visual programming interface for creating flows that connect to MQTT devices and includes a wide range of nodes for processing and transforming data. The other options is Hive MQ is a commercial MQTT broker designed for high performance and scalability, and it offers features such as advanced message routing and clustering and support for custom plugins and extensions. Mosquito is an open source MQTT broker that is widely used in IoT applications, and is lightweight and easy to install and supports QoS level 0 to 2 for message delivery. And the other options is RabbitMQ, that is a message broker and supports a wide range of messaging protocols, including MQTT. And it offers features such as message persistent routing and clustering, and is widely used in enterprise applications. So we have many MQTT brokers, and I call it MQTT brokers list. If I mention later that it can be from any MQTT from our MQTT broker list, I mean this link, and it can be one of them, either Fruit.io, Node-RED, HiveMQ, Mosquito, RabbitMQ, or even a simple Linux machine. That you can have a Linux machine, such as you can have Raspberry Pi, and on that Raspberry Pi you can have you can install your OS, and you can make it a MQTT broker by installing the software that is needed. So we can use we have many different alternatives, and each of these MQTT brokers has its own strength and weakness, and the choice of which one to use will depend on factors such as the specific use case and the level of scalability and performance required, and the need for custom features and integrations. You can install, as I mentioned here, you can install MQTT broker either on the local network, and in local network, it can be either on a Raspberry Pi board or on your computer, which is not as convenient as using a Raspberry Pi board, because you have to keep your computer running all the time to keep the MQTT connection between your devices. In this case, it would be better to use a Raspberry Pi board. Or we say that we have two options, local network or in the cloud. Or in the cloud, you can set up the broker in the cloud, which allows you to connect several IoT devices from anywhere using different networks, as long as they have an internet connection. What is the URI scheme? URI scheme needed for connecting to a MQTT server, and URIs can be used to transfer all the information required to connect to a MQTT server. And the format of the URI is like this: MQTT, or with the S, it means that it is secured. We can have MQTT and MQTT S. colon slash forward slash we call it, and your username and the password @ the DNS, that is host.domain, and port. In the case that you are using MQTT, the port is 1833, and in case that you are using MQTT Secure, it is 8883. So we should know that this is the pattern of how we are connecting. And MQTT client is the other concept. And MQTT client is a software application or device that connects to a MQTT broker to send or receive messages. MQTT clients can be implemented on a wide range of platforms, from embedded devices to desktop computers and servers. MQTT Explorer, that we will go and work with it today, is a client tool that is used to explore and debug MQTT-based applications. And MQTT Explorer is not a standalone entity, and it needs to work with one of the MQTT brokers. For example, in this case, we will install Adafruit on the we will install MQTT broker on the Adafruit, and we will use MQTT Explorer as a client to test our connection to this MQTT broker. So as you can see, MQTT client can be MQTT Explorer, it can be Raspberry Pi, it can be computer, it can be your phone, and it can be your Pico. So this is this is the things that you should know about how they are working together. I don't think that you need only use MQTT Explorer. No, you should have first of all set up your MQTT broker in one of the MQTT broker lists that I told you, and then you should connect and test and debug your connection. I mean your setup using this MQTT Explorer. So MQTT Explorer client is a valuable tool for developers and users of MQTT-based applications, and it can help you understand how the application is working, and you can find the diagnosis and test the application with different MQTT brokers. That's why we need an MQTT Explorer client. We can debug MQTT-based application. We can test MQTT brokers. We can troubleshoot connectivity issues, and we can explore MQTT topics. When we say we debug, when we're working with MQTT-based application, it can be useful to see the messages that are being sent and received by the application, as we will see today. And MQTT Explorer allows you to monitor the MQTT traffic and see the messages in the real time. And testing MQTT broker. If you are developing an MQTT-based application, you might need to test it with different MQTT brokers. MQTT Explorer allows you to connect to different brokers and test your application's behavior. We will see how we should test today. And troubleshooting connectivity issues. Sometimes MQTT-based application may have connectivity issues such as lost connections or drop messages, and MQTT Explorer can help you troubleshoot these issues by providing information about the state of the MQTT connection and the messages that are being sent and received. Exploring MQTT topics. MQTT topics are used to route messages between publishers and subscribers, as we learn. And MQTT Explorer allows you to browse the topics on an MQTT broker and see which messages are being published to which topics. So we talked about remote sensing and remote controlling in the previous lectures. So in remote controlling, you can send a command as a client, like Node-RED in this picture, and control output for and control output, or in this case, the lamp will be on. Or you can send data from a sensor, in this case, sending data from this sensor, and publish it to a client like Node-RED, as you can see in this photo. So MQTT is useful because it is lightweight and uses minimum bandwidth. Let's see one example of remote controlling, that is home automation. As you can see in this photo, a device publishes on and off messages on the home office lamp topic. And you have a device that controls a lamp. It can be a Pico W, as you can see here, and it can be any other microcontrollers like ESP32, ESP82, 60C, or any other boards or device. Here, Pico W or Pico controls your lamp and is subscribed to that same topic. I mean, home office lamp. So when a new message is published, like here, that topic, when this new message is published on that topic, the Pico receives the on or off messages and turns the lamp on or off. On or off. So that is how it works. The device that is shown here that is publishing the messages can be a Pico W, and it can be ESP32, ESP82, 66, or a home automation controller platform with MQTT support like Node-RED or Home Assistant, or many other examples that you can put here as a device. An example of remote sensing. The Pico here request temperature and humidity readings from the DHT11 sensor. Temperature readings are published in the Pico WDHT temperature topic, or DHT11 doesn't matter, DHT/temperature topic, and humidity readings are published in the Pico W DHT11 humidity topic. And Adafruit is subscribed to those topics, as you can see, and receives the sensor readings and displays them on gauge, as you can see here. So let's say temperature humidity that was 2355 that we received from this sensor. Now they are shown here in Adafruit. You can see the values here, the temperature and humidity. So whenever you go, if it is on the cloud, you are set it up your MQTT broker on the cloud, so you will have access whenever you go. So that is how automation is working. You can receive the readings in any other platform that supports MQTT and handle the readings as you want, like Node-RED. The project that we will do is exactly like this way that I explained, and we will publish to a Pico topic, and our Adafruit will subscribe to that topic, and this topic is created in our MQTT broker that is in Adafruit. And after it's subscribed, we will show it the data, temperature, and humidity in the monitoring part of the Adafruit. So Adafruit, in Adafruit, you can create an MQTT broker, or you can have a monitoring, and you can do dashboarding. So MQTT Broker can be any from MQTT Broker list, as I told you, and monitoring and visualization can be either any from the MQTT Broker list or MQTT Explorer that we will go and see today how it is. And here the JSON format for both temperature and humidity values are used. So let's say we have many devices that they want to publish data. We will create this topic as a Pico. These sensors that they are all connected to this Pico, we will publish on the on this topic, and we will see all the values of all the sensors in Adafruit monitoring. So the JSON format will be like this. The device ID, for example, let's say the device ID is 123, and the temperature and the humidity is 23 and 55 for one of them. So we will have this format of receiving data or sending data. Let's see how we can set up a MQTT broker. Let's first of all, you should go to the Adafruit website using the following link, and you need to create account. You need to sign in and create an account on the Adafruit website. So if you have already account, you need to use user and password, and sign in. If you don't have account, you need to sign up and create an account. After that, you will end up in the following URL here, accounts.adafruit.com, and when you are here, you should go to the IO tab, as you can see here, and then click on the yellow key here. When you came to the yellow key, then you should you will have your username, and you need to generate key for your username. So as I had it before, you can see here it's written regenerate because I created before, and when I wanted to show you, it is regenerated. But when you are new and you sign in and create account, you need to generate a key, and the key will be like this: your username and your key. And then after that, you need to create a topic on Adafruit. For creating a topic, you need, if you are logged in already, then it's okay. If you are logged out, you need to log in and then go to the IO tab and choose the feeds tab and choose the new feed button, as you can see here. And then when you when you click on the new feed, you should enter a name for your feed. For example, put it Pico W, and you can also publish on any existing topic which is which is public, such as my topic. For example, either you can create your feed that in this example is Pico W, and it will be in your dashboard in Adafruit, or I have one topic, any other person can have a public topic, then you can also publish on that topics. In my case, it's my username, feeds, and the topic that I called it Pico W, and as you can see, it's here. And then you can set the permission for your feed, such as whether it can be publicly or privately accessible, but feeds by default are private. This is my dashboard. I have the welcome feed is when your login is when you create, this is the by default, and I have two others, pet tree when I was working with the pet feeder, and this is the Pico W that I created here that you can see. And also you should see exactly like this when you are creating. And how we test the MQTT Broker? You should download MQTT Explorer from the following link, http://mqttexplorer.com, and connect your MQTT Explorer to your MQTT Broker using the username and password that you created on Adafruit. Like here, my username was Neda Maliki, and the password that is the key that we had in the yellow key section. I mean here. And this is the username. So this username and password, key, you will put it here. And then after that, you click connect button. When you connect the button, you will end up here in the MQTT Explorer. In this here, in this place, you should you have to write your topic. Topic URI is like this: username /feeds / feed name or key, or username /f, that is short form of feeds /feed name or key. For example, if my username is Neda Maliki, /feeds /pico w, that I put it here. And pico w is the feed that we previously created in our MQTT broker in Adafruit.io. So we choose the row option and we put 1. This is the example, and it can be any other number that you want. This is a message. In this case, I chose 1. That after that, we click the publish button. So when you publish it, if everything is correct, we should see in Adafruit MQTT Broker the message that we have sent by MQTT Explorer, in this case 1. As you can see here, we have this topic that we created before Pico, and from MQTT Explorer, we sent 1 that is ended up in our MQTT Broker. And also, we have another topic that is data formats, and 2 common data serialization formats are JSON and ordered bytes. JSON is a lightweight data interchange format commonly used in IoT applications and is a useful way to store and exchange data between different applications and systems. And it's easy for humans to read and write, and easy for machines to parse and generate. And it uses a simple text-based syntax to represent data structures consisting of key-value pairs, arrays, and nested objects. As you can see here, and I talked about these structures in, I remember, lecture 4. So how JSON looks like is a key, and this is the value. Is a key, and this is the value. Pressure is a key, and the value is 1023. Temperature is a key, and the value is 23. And they are separated by comma. Each key value is separated by comma. So we know about the JSON format. The other one is ordered bytes, that also I talk about it, and is a binary data serialization format that is optimized for performance and space efficiency. And it represents data structure as a sequence of bytes in a specific order, with each data type represented by a fixed number of bytes. Both JSON and ordered bytes have their own strengths and weakness, and the choice of which one to use will depend on factors such as the specific use case and the data size and complexity, and the performance and compatibility requirements. And in general, JSON is a good choice for human-readable data formats, and that can be easily parsed and generated by a wide range of programming languages and platforms, while ordered bytes is a good choice for high-performance data serialization and deserialization, especially in low-level systems where space and performance are critical. We will have an assignment that is in 2 parts. The first part that I want you to do it is the things that you learned today, and it is set up an MQTT Broker server on Adafruit, and create a topic and message on Adafruit, and set the permissions, and test it with the MQTT Explorer. And the assignment part 2 that we will cover in the next lecture is that we will connect the MQTT client, I mean the PicoW, to the MQTT broker via Wi-Fi. We already learned how to connect our Pico to Wi-Fi, but we don't know how to connect our Pico to MQTT broker. So we will cover it in the next lecture. And after that, send the mock temperature data to the MQTT broker, or send the real data, temperature data that we get from the sensor to the MQTT broker that we have in Adafruit. So for now, we just need to do these 3 steps. That is the first part of the assignment. And we will cover the second part in the next lecture. So let's see what we have learned. We learned what is MQTT protocol. We learned how the publish subscribe model works, and we learned the 3 levels of QoS in the MQTT protocol, and we got to know the message and topic concepts. And also we learned what is MQTT broker, and we got to know many different kinds of MQTT brokers. And also we learn how to create an MQTT broker on Adafruit and how to test it using MQTT Explorer. And the next will be connectivity with Wi-Fi, that we will go through how we connect our Pico to the MQTT broker that is that we created in Adafruit, and send the temperature and humidity values to our broker. Hope you enjoyed this lecture. If you have any question or feedback, please write me on a Slack, and always you are welcome to my office. And thank you for your time. Bye.